The earth is thought to be this stagnant place where human beings stay in regular places for a long time. But genetic history does not bear this out. We look all over the world and over again we're shocked by what we see. From places as far away as America having DNA from Austronesians, or places as close as Africa having Austronesian DNA. This meaning that there were extremely large migrations that fused the world back in the day in a way that is thought to be impossible for almost any other group back then. But in 2022, there was a study done on the genetic founders of certain populations dating back 10,000 years ago and as soon as 500 years ago. So you could track the difference between when the slave trade happened, bringing West African DNA into the Americas, and 10,000 years ago. Now, you would expect that there should be no DNA from 10,000 years ago of black Africans, but they found quite the opposite. They found 3%. And the way they justify it is kind of telling of what people were expecting to find and what they found. And of course, this would jumpstart something very crazy if there was 3% DNA in the Americas from Africa 10,000 years ago. Before I carry on, please subscribe. Remember, I'm only 50 away from being monetized. I don't know, get a grandmother, your mother, your children, whoever to subscribe. I only need 50 people till I'm monetized. So let's just get straight into it. It says, for the founder analysis of maternal lineages into North and South America, we maintained the two migration events. This allowed testing of the discriminatory capacity of the methodology. Our analysis allocated 6% of North American and 3% of South American sub-Saharan lineages to the Holocene. We'll discuss what the Holocene is soon. This could be explained by statistical residual from the recent lineages, but also from a couple of lineages whose founder in Africa were likely not detected, or due to minor errors in the sequences leading to overestimates of the age estimate of specific lineages. Nevertheless, even considering these sources of error, it is clear that only recent migrations, mainly associated with the transatlantic slave trade, are significant. Significant meaning having a big amount. They don't mean this, it doesn't matter at all. So the Holocene begins at about 11,000 years ago. If we try and track this, this is like 8,000 BC. So 8,000 BC, and markers of this time is we start seeing early buildings, we start seeing bow and arrows being used, we start seeing early versions of farming and even some very sophisticated farming in Africa, Asia, Europe. In fact, we start seeing pottery at this time. So this is a huge transition from what happened before. But remember, the Holocene is only after the Pleistocene, in which the Pleistocene we started seeing some transitions away from the hunter-gatherer lifestyle as well. Now, I don't want you to get confused. The Holocene is more of a geological thing. It's talking about what geological state we're in right now, and we're in the Holocene starting 11,000 years ago. Before that, there was the whole ice age or the glacial period, and in that glacial period, that was the Pleistocene, and we saw certain things. So, like I said, we find sub-Saharan African DNA in America during the Holocene, the early Holocene, a couple thousand years ago. Now let's review the study as a whole. So the heading is Phylogeography of Sub-Saharan Mitochondrial Lineages Outside of Africa highlights the role of the Holocene climate changes and the Atlantic slave trade. Despite the importance of ancient DNA for understanding human prehistoric dispersal, poor survival means that data remain sparse for many areas in the tropics, including in Africa. In such instances, analysis of contemporary genomes remain invaluable. One promising approach is founder analysis, which identifies and dates migration events in non-recombing systems. However, it has yet to be fully explored as its application remains controversial. Here we test the approach by evaluating the age of sub-Saharan mitogenome lineages sampled outside Africa. The analysis confirms that such lineages in the Americas date to recent centuries, the time of the Atlantic slave trade, thereby validating the approach. By contrast, in North Africa, Southwest Asia, and Europe, roughly half of the dispersal signals dates to the early Holocene. During the greening of the Sahara, we elaborate these results by showing that the main source regions for the two main dispersal episodes are distinct. For the recent dispersal, the major source was West Africa, but with two exceptions: South America, where the fractions from Southern Africa was greater, and Southwest Asia, where Eastern Africa was the primary source. These observations show the potential of founder analysis as both a supplement and complement to ancient DNA studies. Whilst the longer term emergence of Homo sapiens was likely the result of multi-regional process across sub-Saharan Africa, fossil cranial morphology, contemporary genomes, and ancient genome-wide variation sampled over the past 18,000 years all point to a tripartite population structure within sub-Saharan Africa. Such population structure had previously been recognized by maternal inherited mitochondrial DNA genome analysis that established a chronology for the settlement of such groups through migrations that occurred 100,000, 200,000 years ago, determining three groups of anatomically modern humans in Central, West, Eastern, and Southern Africa that are clear at the phenotype and genome-wide levels. A recent study using ancient genomic data suggests that by 5,000, a cline existed between these three sources of modern human ancestry. On the mtDNA phylogenetic tree, the first major split in the extent variation dating to nearly 200,000 years ago, using various approaches, occurred between macro haplogroup LO, typically found in indigenous Southern African Khoisan click speakers, and the remaining L1, 2, 3, 4, 5, and 6, and L1, 6 for short, branches distributed across populations further north. This primary south-north divergence has also been detected at the genomic level. On the northern side, African haplogroup L1 split first from L1, 2, 3, 4, 5, 6, 7, 150,000 years ago, representing Central and Eastern African clades, respectively, followed by L5 within Eastern Africa 130,000 years ago, while L2, 3, 4, and 6 diversified mainly in Eastern Africa. L2 split from L3, 4, and 6 into West Africa after 100,000 years ago via a route. This is not completely clear. About 60 to 75,000 years ago, L3 arose in Eastern Africa and expanded dramatically, promoted by the population growth of Eastern African populations. This may have been fueled by the moisture conditions following a major drought and the possible arrival of novel uses of symbolic activities and technology associated with aspects of modern behavior that took hold in southern Africa. Refugia 130,000 to 75,000 years ago. This is suggested by major dispersal of allo lineages from southern to eastern Africa occurring in this time, and many have led to the establishment of long-term networks between South and Eastern Africa. As a result of these expansions, Central on Eastern Africa L3 is today well represented across Africa, including in deep clades in Central and West Africa, and also encompassed all non-African mtDNA variations following dispersal of out of Eastern African into Eurasian that took place as part of the same process. Reciprocal exchanges are also evident. For instance, haplogroup L2 lineages also show signs of being transmitted back from West Central to Eastern Africa people around this period. The following 40,000 to 50,000 years witnessed little significant population movement within Africa and variation accumulated regionally, likely due to a fragmented environment. However, in climate changes introduced during the Holocene allowed woodland and savanna adjacent to the Sahara to expand, creating conditions for the Sahara to become a major corridor both north, south, and east, west. The expansion of L3 lineages in Eastern Africa and L2 lineages in West Africa attest to the rise in human mobility across the Sahel. During this period of improved climate, movement northwards of Eastern, Central, and Western population also led to the arrival of sub-Saharan mtDNA lineages in North Africa and eventually Europe, which was most likely the largest movement of people from sub-Saharan Africa into Europe and Asia since the out of Africa migration. By the end of this period, Africa might have also witnessed the expansion of pastoralism across the northern range of the continent. From 4,000 years ago, another major expansion substantially shifted the genetic structure of the African continent. The dispersal of Bantu speakers, driven by the mastering of agriculture and the iron smelting technique. These migrations began between Nigeria and Cameroon and followed two main routes into southern Africa. Western route directly into Angola, Botswana, and South Africa around 3.5 thousand years ago, and an eastern route into the Great Lakes in Uganda at 2.5 thousand years ago, and from there southward into Mozambique less than 2,000 years ago. All these demographic events over the last millennia have reshaped the earlier genetic diversity and establishment and current population genetic structure within Africa, which is phylogeographically well studied. In the last 500 years, major forced migration from Africa into other parts of the world have occurred. While slavery had been present in human societies for thousands of years, the scale of the Atlantic slave trade was unparalleled from the 15th to the 19th century. More than 10 million Africans were carried into Europe and especially into the Americas. The European slave trade started in West Africa in the 15th century in the region then known as Senegambia, between the Senegal and Gambia rivers. In the ensuing years following the settlement of European colonies along the west coast of Africa, other regions became more important sources of slaves, including Mina, the current Ghana Benin region. Historical records suggest that these regions contributed up to two-thirds of slaves, followed in the 7th century by Angola, located further south. The precise region, origin, and ethnicity of the people forced to travel is not well documented, although a general overview of the dominant ethnicities exists, and a genetic picture has begun to emerge from both mtDNA and on a genome-wide level. Phylogeographic analysis is useful to shed light on unknown aspects of migration that occurred across the African continent. This is a methodology that employs the phylogenetic reconstruction of non-recombining genome loci and the nesting of lineages coupled with geographic information to infer the timing and the direction of migrations. Founder analysis, in turn, is the formalization of the phylogeographic methodology applicable when a source and sink population can be established. The clear African origin of human mtDNA lineages offer an opportunity to test the accuracy of the founder analysis approach using a controlled case scenario, such as the long distance gene flow mediated by the Atlantic slave trade into North America, and to simultaneously investigate both the timing and the magnitude of other less well understood dispersal events into Europe, Asia, and the source of the founder lineages within Africa. Before we talk about the results, let's talk about some standouts that I was reading in what we just read. First of all, it proves something that I said a long time ago, which is that sub-Saharan Africans that separated in two directions, bifurcated in two directions in the Holocene, close to our time, right? Or our time, but early to our time. And they went to North Africa in two directions, meaning that East Africans went through Egypt and then out into the Middle East, and West Africans went into North Africa. And you saw there that they mentioned that there was the second migration from Africans, probably during the Holocene, into Europe via North Africans. So here they're coupling it with North Africans. You got North Africans and their founder DNA from sub-Saharan Africans that goes into Europe. In other words, Europeans have some sub-Saharan African in them that comes from that direction, probably staying closer to the south, places like Spain, Portugal, France, those areas. Maybe it doesn't go as north as Sweden. I don't know. Keep in mind that this is a sum up of what we already knew. So, in other words, this is a more accepted view of what happened in history, meaning that the previous results that have been shown have had some standing in the fact, because a lot of people were questioning me last time. They're like, oh, what the hell? You don't understand genetics. Clearly, now it shows that I was right in saying that the Natufians and all these other people who in North Africa who traveled into Europe were carrying some sub-Saharan African DNA. And remember, it said later than this movement, the Out of Africa movement. So closer to the Holocene, our time. Following the data collection, alignment, and quality control during phylogenetic analysis, we obtained a total of 6,048 mitogenomic whose identification, location, and haplogroup classification are displayed in Table SI. We performed founder analysis using 6 scenarios aiming at either the validation of the methodology or the at uncovering specific aspects of past population movements, including African mitogenome lineages. A list of founders is displayed in Table S2 to totaling 74 founders for North Africa, 114 founders of Southwest Asia, 78 founders for Europe, 51 founders for Iberia, 285 founders for North America, and 25 founders for South America. The result of the scans for the 6 models of founder analysis across the last 25,000 years are displayed in Figure 1. For the founder analysis of sub-Saharan lineages into North Africa, and for both North and Sub-Saharan lineages as the source into Southwest Asia, Europe, and Iberia alone, we obtained striking results. The migration scans indicate 2 main peaks of migration, one in the early Holocene around the Holocene climate optimum 7.4 thousand years ago to 10,000 years ago, and another in the present or close to the present at 0,000 years ago. We see an absence of movement carrying sub Saharan lineages between those periods. As expected for North and South America, we see only recent episodes of gene flow. Overall, the clarity of the patterns highlights the strength of the analysis performed. However, some small bumps at about 1,000 years ago most likely represent arrivals with the transatlantic slave trade, possibly conflated with a few earlier minor movements in the case of Europe, and probably artificially inflated due to the presence of a small number of sequencing artifacts, which would have a disproportionate impact at this timescale. It is almost possible that the mutation rate correction for purifying selection at this very recent time depth is insufficient. Given the high number of founders detected in North America, it is even possible that this number is still underestimated, since while the main lineages were detected, some of the variation within those lineages might have already been carried to North America, therefore slightly increasing the estimated founder ages. Further sampling of African populations, especially West African populations, should help to settle this issue. So again, in the result, they restate the fact that they find DNA from Africa that shows early Holocene intrusion from sub-Saharan Africa through North Africa. And then they say they find no traces of North or South American DNA from that early period, and they find it only later in the slave trade. Making this assumption and given the above results, we performed a second analysis stipulating a model with 2 migration events. The first is at 8,000 years ago, corresponding to the Holocene climate maximum, accounting for the 7.4 to 10,000 years ago peaks in the founder analysis into North Africa, Southwest Asia, Europe, and Iberia. And the second is at zero point 0.5 thousand years ago, which is 500 years ago, corresponding roughly to the start of the Atlantic slave trade, which will statistically allocate any events within the last few millennia, and founder lineages identified can be further analyzed phylogeographically for a better definition. Figure 2 displays the result of the founder analysis using the two migration models, respectively labeled as prehistoric and historic. Figure 2a, it is important to note that the general founder lineages are statistically allocated to one migration or the other, with little evidence of gene flow in between as suggested by the scan. Furthermore, we verified the phylogenetic tree structure and phylogeographic for each founder to pinpoint their most likely African broad region of origin. The results for North Africa suggest that about half of the sub Saharan lineages arrived in the early Holocene and the other half in recent times. However, when analysis the putative source location of the lineages in each migration event, the distribution differed amongst the prehistoric arrival. Half of the North African mtDNA founders were from West Africa, with much of the other half associated with Eastern Africa. However, there was substantially more lineages from West Africa and correspondingly fewer from East Africa when considering the origin of lineages in recent times. Again, the present day sub Saharan African lineages in Southwest Asia are distributed nearly 50-50 between prehistoric and historical arrival, although with different distributions in present day populations. The phylogeographic analysis showed that the majority, 86% of African lineages, are arriving in Southwest Asia in the historic period, where from Eastern Africa, the exchange of female lineages between Eastern African and Southwest Asia, mostly Arabia, in the post glacial period from 15,000 to 7,000 years ago has been documented before and is supported again here, displaying up to a frequency of 4 to 10% in current populations. Curiously, for the recent arrival, which reach frequencies of up to 13% in Arabia, although the majority are again from Eastern Africa, 68%, there is significant fractions of lineages arriving from West Africa, 22%. There you have it. African DNA in Western Asia, meaning the Middle East, in significant numbers. This might be the Afro-Asiatic movement, although they say here it's 15,000 to 7,000 years ago. The prehistoric times that come from Eastern Africa. So there you have it. And then you get the later ones from Western Africa and Eastern Africa. This probably has to do with the slave trade and other earlier periods, like Egyptians moving into the Middle East, and North Africans moving to the Middle East, and East Africans moving to the Middle, the Abyssinians and people like that. They then insert a graph to show this frequency of sub Saharan lineages in Europe and Southwest Asia following the statistical location into prehistoric arrivals, which is A, and he's torusal arrivals in B, plus estimated using the Kriging algorithm of the Surfer 8 software. For Europe, our founder analysis suggests that there are more African mtDNA lineages related to prehistoric than the historical period. Note, however, that most of the lineages here considered in the European analysis are from Iberia, as displayed in the figure 3. For both prehistoric, figure 3a, and historical arrivals, figure 3b, typically North African lineages are well represented in the prehistoric period. That the Minoans of Crete have these two colors around them. Even though their hair is long and wavy, you notice that they have dark skinned people and they have light skinned people. Now, this could be two things. One, it could be admixture from Africa, or it could be the early European hunter gatherers who had dark skin that left it over. Some people wanted to suggest that it had to do with symbolism and that this wasn't actually their skin color, but that theory holds no water, especially if you notice here the symbolism they said was making women lighter skinned and making men darker skinned, which they copied from Egypt. One, that theory doesn't make sense because it's not even true in Egypt. But if you look here, the these are men who are light skinned on the ends, and this is a man jumping the bull in the middle. So these are not symbolic at all. So we continue to read. When considering historical migrations, although gene flow across the Mediterranean must again have played an important role, the North African influence diminishes, with West African lineages becoming more dominant, representing three-quarters of the migrants. This suggests that a higher percentage of recent migration from West Africa into Iberia and Europe took place without crossing North Africa. Furthermore, some lineages arrived directly from Southern Africa at minus 9% in Europe and 9.5% in Iberia without being detected either in North or in West, Central, or Eastern Africa. We did not detect this for arrivals in the early Holocene, and this likely reflects the more extensive sea crossing of the last 5 centuries or so. These might be the Moors. For the founder analysis of maternal lineages into North and South America, we maintained the two migration events. This allowed testing of the discriminatory capacity of the methodology. Our analysis allocated 6% of North American and 3% of South American sub Saharan lineages to the Holocene. This could be explained by statistical residual from the recent lineages, but also from a couple of lineages whose founders in Africa were likely not detected, or due to minor errors in the sequences leading to overestimated of the age estimate of the specific lineages. Nevertheless, even considering these sources of errors, it is clear that only recent migrations, mainly associated with the transatlantic slave trade, are significant. This is what we read earlier, and as you see here, it's being explained away, but it has shown up in the Holocene as a genetic thing. Now, we can't say it's significant because they said it's insignificant, so we will take their word for it. I'm not going to doubt them. I've been basically going with them this whole time. Why should I start bending away from them now? They're saying that it's there, but it might be some kind of error. Now, if it's an error, that's fine. But if it's not an error, what does that mean for early Americas? Does it mean that there was a lineage of sub Saharan Africans that migrated to the area earlier? Or does it mean that there's a jump in DNA that happens from sub-Saharan Africa to the Americas that happened somewhere in Asia that was not accounted for, and then it just somehow ended up in America because it traveled with the people? Does this mean that Africans have already traveled later in life than before what we first thought? This genetic diversity might be able to explain away why Americans look so different from one another. For example, why people in Canada are so light skinned. In North America, they're so mid tone, but then when you go down to the South American Peru regions, you start seeing people who are dark skinned. But not only that, they start to engender like African facial features. This might be the reason, and it might be the reason why we see some of those statues that a lot of people like to bring up that kind of look like black people. So finally, we get to the last part. As for recent mtDNA lineages in North America, mostly labeled as African Americans in the database, more than three-quarters are originally from West Africa, with nearly 15% arriving from Southern Africa. We see a striking contrast between North and South America. South America shows more than half of the lineage, 55%, arriving from southern Africa, mostly Angola, from the phylogeographic inferences, against 45% from West Africa, pinpointing an increased importance of the southern African people being transported to South America. So here we have the transatlantic slave trade being labeled. So you notice that the one before was not the transatlantic slave trade. This is. States. In this work, we estimate the timing, the proportion, and the broad geographic origin of relevant movement of African mtDNA lineages outside of sub-Saharan Africa using a phylogeographic based approach, and more specifically the founder analysis methodology. Previous inferences regarding the presence of sub-Saharan mitogenomes in Europe have highlighted movements from North Africa following the Ice Age, and with the onset of Holocene Africa 8.9 thousand years ago, including gene flow specifically to Iberia, we are able to contrast the proposed Holocene event with a recent and well-known event, namely the slave trade, and eventually more recent migrations and quantity, the impact of each of the maternal gene pool. The founder analysis scans into North Africa, Europe, and Southwest Asia all showed two major periods of migration, one in the early Holocene and a much more recent one. Thus, these movements were not random. Thus, these movements were not random, but rather concentrated in specific time periods following the out of Africa migration 60 to 70,000 years ago. Significant migration of sub Saharan lineages did not disperse from the continent again until the early Holocene. At this time, the climate optimum and the consequent expansion of equatorial forest allowed movement that had previously been limited. Populations were able to cross a greener Sahara to North Africa and Southwest Asia, and from there into Europe, as suggested before. It doesn't get more clear than that, does it? And I won't keep boring you by talking about more stuff, but if you want to, I'll link it in the description. And it says that Africans later then came in, and then they came in, and then there was the slave trade, and then there was other stuff. So, if we want to know about the fact that Africans have traveled into North Africa, and the funny part is, they're mentioning stuff that I knew already existed, like the greening of the Sahara allowed people who are from Africa to cross the Sahara in a more effective way, thus leading them to populate some parts of Europe, like the Iberian region. No surprise to me there. No surprise. I wonder if you're surprised. If you weren't surprised or you were surprised, consider subscribing, sharing, donating, whatevering.